So today we will study V engine. This is a twin cylinder V engine. This is the line of stroke of the first cylinder and this is the line of stroke of the second cylinder. This is the vertical line and this is alpha. This is alpha. So alpha is the angle between the line of stroke and the vertical, and the V angle is twice alpha. So please remember, the V angle is twice alpha, not alpha. The V angle is twice alpha, and this is the common crank, and the crank angle is being measured from the vertical. The crank angle is measured from the vertical. So that means now you see, so from this line of stroke, the crank from this line of stroke, the crank makes an angle of theta minus alpha, and from this line of stroke, the crank makes an angle of theta plus alpha. So the unbalanced force, the primary and secondary unbalanced force, F1 would be m omega square r, where m is the reciprocating mass, m omega square r cos theta plus alpha, because from this line of stroke the crank angle is theta plus alpha. Theta is being measured from the vertical, and for F2 is along this line of stroke. F2 is along this line of stroke. F2 is m omega square r cos theta minus alpha, because this angle is theta minus alpha plus cos 2 theta minus alpha by n. So this is the primary part, this is the secondary part. So this is the primary part, this is the secondary part. Now if you take the component along the vertical and the horizontal, so horizontal we have taken in this direction, then Fv is equal to F1 cos alpha plus F2 cos alpha. Fv equal to F1 cos alpha plus F2 cos alpha. So cos theta plus alpha cos alpha plus cos theta minus alpha cos alpha plus this cos alpha plus this cos alpha, and by n is coming. So this is the vertical, the unbalanced force along the vertical direction. This is coming from the primary part and this is coming from the secondary part. So if you do a little manipulation, then just you expand this and do a little bit of manipulation, you get, or here you expand this and do a little bit of manipulation, this is what you get: cos theta into 1 plus cos 2 alpha and cos 2 theta by n cos alpha plus cos 3 alpha. And if you take the horizontal direction, this one is the horizontal direction, then it is F1 sin alpha minus F1 sin alpha minus F2 sin alpha. This is F1 sin alpha minus F2 sin alpha. So sin alpha into F1, so for F1 this, and sin alpha into F2. So this is the resulting expression, and if you expand this, then you get this. So this is the force along the vertical direction, and this is the force along the horizontal, unbalanced force along the horizontal direction. So there are some special cases. Actually, for V engines we generally the popular V engines are 60-degree V engines and 90-degree V engines. For 60-degree V engines, alpha equal to 30 degree. So if you put the value of alpha here, if you put the value of alpha here, if you put the value of alpha, not here, maybe here, if you put the value of alpha here, 1 plus cos 60 plus cos 2 theta by n into cos 30 plus cos 90, then you get this as your Fv and this as your Fh. So, and if alpha is 45 degree, then generally this configuration is used, that is V angle is 90 degree. So 90 degree V angle is generally used. Then you get Fv, the primary part. For Fv you are getting the secondary, the contribution from the secondary part is nothing here. and here this is the primary part and this is the contribution from the secondary unbalance. So now if you notice that if you just concentrate on the primary part, there is one m omega square r cos theta in the vertical direction and m omega square r sin theta. This is minus, so we have taken h in the leftward side as plus, so minus means if h is in this direction. So if m omega square r sin theta is the only primary part, and the vertical component of the primary part, the horizontal component of the primary part, since it's negative, it will be in this direction. So the resulting unbalanced force is along the crank. So if you put opposite force in the other side of the crank, then that would balance this unbalance. So for 90-degree V engine, the primary part can be completely balanced by a mass at crank radius and opposite to the crank. So this is the special advantage of 90-degree V engine. And if alpha equal to 90 degree, that is twice alpha is 180 degree, that is the center lines, that is these two center lines, the angle between these two center lines are 180 degree, then it is called an opposed piston engine. For the opposed piston engine, if you put alpha equal to 90 degree in the expressions we have derived, you could get F equal to 0, and this is FH. So this is our discussion on twin cylinder V engine. So this is actually the last topic in the balancing part of this course. So let us stop here and we'll continue in the next class, and we'll start our next chapter.